Hey guys, today I'm gonna talk about the physics in basketball. And the first part is my poster. And as you can see, there is some basic information about physics in basketball, and there is two topics, which is the hang time and the physics of basketball backspin, and this is I will introduce it today. So back to our major, and today I'm gonna talk about the physics in basketball. And the first part, as you can see, is how can we make the moving shot more accurate? And I think the answer is most accurate throw is generally just a little faster than the minimal required speed to get your projectile to the target. If you are going to throw something at a high speed, though a shallow overhand throw is best, especially if the target you want to hit is below your shoulder. The next part is my intro video. Hey guys, I'm Luke, and this is my intro video of my whole project. And the first, I will talk about the history of basketball. Nowadays, the basketball is the most popular sports around the world. So today I'm gonna talk about some early history of the basketball. The first part is the invention of the game. The game of basketball, as it is known as today, was created by the Dr. James Naismith in December 1891 in Springfield, Massachusetts, to condition young athletes during cold months. Naismith was a physical education instructor at YMCA International Training School in Springfield. Upon the request of his boss, Naismith was tasked to create an indoor sports game to help athletes keep in shape in cold weathers. It consisted of pitch basket and a soccer. In the second part, I will introduce the physics of basketball. The jumping is a major component in the physics behind the basketball. When a basketball player jumps into the air to make a shot, he can appear to the suspended in mid-air during the high point of the jump. This is a consequence of projectile motion. When an object is thrown in the air, it will spend a large percentage of time in the top part of throw. So I will introduce this part in the PowerPoint. Thank you. So right now, let me start my presentation. And the first part is a hang time. As a basketball player, they can jump as much as 4 feet in the air. And the higher he jumps, the greater the hang time. And the greater the time he will appear suspended in mid-air during the high point of jump. Typically, there is a horizontal and vertical component in the jump velocity at takeoff. The magnitude of the vertical component of the velocity at the takeoff will determine the time the player spends airborne. Thus, the vertical component of velocity after takeoff will change with time, and the horizontal component of velocity remain constant throughout the jump, since it is not affected by gravity. It shows that the typical trajectory a basketball player might travel as he makes a jump. So next is my model, and you can see it's like a projectile motion. And you can visually see almost half of hang time is spent near the top of the arc. Using some mathematics, one can calculate the time spent in top part of jump. And as you can see, there is some calculate apps during the picture. And this is also interesting result tell us that half of hang time is spent in the bottom 75% of the jump. And the next part I will introduce is the backspin. And the backspin is used by players to improve their chance of getting the basketball into the net. When an object is spinning and bounces off something, it will have a tendency to bounce in the direction of the spin. This is useful for players who bounce the basketball off the backboard or the back of the net. The resulting bounce will more likely to send the ball downwards into the net. Without the backspin, the ball is more likely to bounce away from the net. So that's all. Thank you.